Okay, here is a program. I'm going to go over all the details. Let me just run it, and then I can tell you how to make it. So the idea is it's for a question. And the question is two cars start with the same momentum, and there's a force pushing to slow them down. If they have the same starting momentum, which one takes longer to stop? So this runs, so you can see here, the red car is a heavier car, the blue one is the lighter car. They start with the same momentum, so this blue car has to have a larger velocity. But according to the momentum principle, they'll stop in the same time. Now, the question was, which one's going to start in a greater distance? And you can see the answer there. But let's go and look at how we make this program, because there's some details that are useful. This first line, scene, that just makes the background white. I don't know. I just felt like having it white. Okay, car 1 is an object of a type box, and it starts -5x value, and then this is the size. This is the color, blue. Now here's the cool things. Make trail true. That leaves a trail behind it, just for fun. You don't need that. If you leave that as just make trail true, you get a line. Make trail type equals points leaves dots. Interval leaves a dot every 40th calculation. And then trail radius, if you don't do this, it's a little too small, so I just picked a different size for the dot size dots. And then car 2 is the same thing. The only thing different is that I put it with an initial value of -1 in the y direction and a color red, but other than that's the same. Here I make the masses of the two cars. Car 1 has a mass of 10, car 2 is 30. I set the initial momentum at 20 for car 1, and I set that equal to car 2, also car 2 momentum. This makes the arrow for the velocity. Let me run it again. You'll notice that this has an arrow indicating the velocity, so you can see that it's slowing down, and that one's slowing down too, but they both stop at the same time. There's another way to do this, but I did it the long way. So I gave it a position, the axis is the size, I made it half of the velocity just because for scaling. And the fixed width, that just means that as the arrow gets smaller, it still stays the same width. It doesn't make just a tiny arrow. And so arrow 2 is for car 2, arrow 1 is for car 1. That's pretty simple. F is the backwards force, so it's in the negative x direction with a value of 2. T is 0, starts the time step of 0.01. Okay, now, while the car's 1 momentum in the x direction is greater than 0. So this does the loop until the car stops. Rate says only do 100 calculations a second because this is at 1/100th of a second. So if I change this to 1,000, it's going to run super fast. See? And you can make it run slow by making that 10, but let's put it back to 100. Okay, line 28, this is the momentum update formula. So it updates the momentum of car 1 based on that force and the time interval. And then car 2 does the same thing. So the momentums of the cars are the same at all times because the forces are the same. Line 30 is updating the position of the car. So here you see I have car 1p times dt divided by car 1.m. So this is actually velocity times dt. And so they have different velocities. Car 2 has a different velocity because they have different mass. So they'll slow down differently. These next lines just update the arrows, and that updates the time, and then that's it. Run the program, and you can see that. So here's what you want to do. See if you can take this program and change the initial momentums. Pick whatever values you want. Actually, just change it for car 2. Change it for car 2 so they stop in the same distance, not in the same time. Okay, see if you can do that. That is your homework assignment.